On a remote peninsula in the South Pacific, a rocket and 10 small satellites are about to launch a new era in spaceflight. Rocket Lab's Electron rocket is a new player in the space arena, and those tiny spacecraft, called CubeSats, represent big dreams.
It's kind of like the preeminent, most exciting mission within the whole company. The whole team is just incredibly excited to have that NASA logo on the side of the vehicle and fly those payloads.
The NASA payload about to launch on the Electron rocket is called ELaNa-19. ELaNa stands for Educational Launch of Nanosatellites, part of NASA's CubeSat launch initiative. This is the agency's way of providing a path to space for CubeSats, compact satellites that pack a lot of science into a package about the size of a loaf of bread.
Space is no longer just for high-value science or the intelligence community. It is a place for a payload that you can create that can get up to space.
Until now, CubeSats have always launched with larger spacecraft, but flying as a hitchhiker limited where they could go and the science they could do. That's what makes this Rocket Lab flight so historic. It's the first time these small satellites are the stars of their own show, flying on a rocket designed for their needs. The 10 CubeSats flying on ELaNa-19 were developed by teams from across the nation, from high schools and universities to NASA field centers. Da Vinci was developed by a student-led team at North Idaho STEM Charter Academy. It's designed to connect to students around the world by broadcasting education-related messages through amateur radio in Morse code. It also carries a Global Star modem and ArduCam, allowing users to upload digital messages or see photos of Earth from orbit.
I don't know if anyone remembers like the Ovaltine messages and stuff on the radio way back when, but our goal is to do something like that where they have to tune in every week or every other week to get this new message and decode it and really dive into that information so that they develop an interest in space and they say, oh, hey, I can communicate with something that's not even on this planet.
RSAT was developed by a team of midshipmen from the U.S. Naval Academy in Annapolis, Maryland. This crab-like CubeSat has a pair of robotic arms designed to grab a host satellite and maneuver around it to take photos, or potentially even make repairs if a spacecraft isn't working properly. The CubeSat STF-1, or Simulation to Flight 1, is a collaboration between NASA Independent Verification and Validation Program with West Virginia University and small businesses. STF-1 will monitor space weather over Earth's poles and test the durability of new materials for use in LEDs. But it's also designed to demonstrate a simulation and test platform to aid in the development of future CubeSat missions. These CubeSats show that small satellites have an important and growing role in space exploration. NASA's Venture Class Launch Service was created in 2015 to provide CubeSats their own ride to space, expanding launch and science opportunities for small satellites and sparking a brand new segment of the space launch industry. Rocket Lab's Electron rocket is one of 2 vehicles NASA selected for Venture Class missions. It's smaller and lighter than other launchers in NASA's stable, but that's the whole point.
The intent is for the Venture Class launches to occur at a rapid pace that match the iteration and design cycle that CubeSats can go through. So instead of having a launch for a primary mission once every 2 years, once every 5 years, the real goal is to see Venture Class rockets get to a cadence where they can see regular access to orbit.
Many of the CubeSats on the ELaNa-19 mission are designed to benefit future missions. Shields 1 was developed by NASA's Langley Research Center in Hampton, Virginia. Its objective? To test materials that could be used to shield spacecraft against radiation.
This is a radiation effects experiment where we're looking at the performance of the materials and the electronics, and it would have a potentially large impact for improving performance of future spacecraft.
NMTSat was built by approximately 50 undergraduate and graduate students, primarily from New Mexico Tech in Albuquerque, New Mexico. It's designed to use onboard sensors to collect data on Earth's magnetic field, take atmospheric weather measurements, and carry out an optical beacon experiment. The next spacecraft was developed by teams on opposite sides of the country, in Florida and California. It's called CHOMPT, which stands for CubeSat Handling of Multi-System Precision Time Transfer. This mission is a collaboration between the University of Florida in Gainesville and NASA's Ames Research Center in Mountain View, California. CHOMP uses lasers instead of radio waves to demonstrate new ways to navigate and network satellites in deep space. The Advanced Electrical Bus, or ALBUS, was developed by NASA's Glenn Research Center in Cleveland, Ohio. ALBUS will demonstrate shape memory alloy mechanisms for deployable solar arrays. It'll also serve as a pathfinder for high power density CubeSats.
The shape memory alloys themselves are really good technology because they are low mass, they can produce low shock, and we can reset them. So we can actually reset our mechanisms to test it again to deploy to make sure we're going to have a successful mission.
While the CubeSats are prepared for flight, their ride, the Electron rocket, begins to take shape. Fully assembled, the Electron stands nearly 56 feet tall, a smaller rocket dedicated to launching small payloads. It's a 3-stage carbon composite vehicle, topped by a payload fairing to protect the CubeSats during launch. The Electron's engines and avionics are manufactured here in the United States at Rocket Lab's facility in Huntington Beach, California. In fact, the company's Rutherford engine is the first ever oxygen kerosene rocket engine built using 3D printed main components. Then they're sent to Rocket Lab's facility in Auckland, New Zealand. Here, the company puts its engines to the test before final integration. It's also where Rocket Lab manufactures the vehicle's stages and payload fairing. But until the rocket is assembled and tested in New Zealand, the CubeSats will wait in California. It will all come together when the spacecraft arrive from Huntington Beach just a few weeks before launch. CubeSail was built by the University of Illinois at Urbana-Champaign in CU Aerospace. It carries a 250-meter solar sail ribbon, technology that's being evaluated for use on future spacecraft, such as scientific missions to interstellar space.
CubeSail is going to be doing a technology demonstration of the deployment technique as a stepping stone towards even larger missions we have planned on the road, like iSail and UltraSail.
The ISX CubeSat, or Ionospheric Scintillation Explorer, is a collaboration between SRI International and Polysat at Cal Poly San Luis Obispo, California. ISX is designed to take a closer look at plasma fluctuations in the upper atmosphere and learn more about how they affect radio communications with satellites. Up next is Ceres, the CubeSat Compact Radiation Belt Explorer. It was developed by NASA's Goddard Space Flight Center in Greenbelt, Maryland. Ceres will fly into Earth's Van Allen radiation belts to study the high-energy particles streaming toward the Earth from the Sun and learn more about how electrons in the radiation belts are energized and lost.
CubeSats go into the clean room and they do their standalone processing. So that's any sort of checkouts, charging. Basically, they're getting ready to get into that final package, the dispenser. That's the piece of hardware that's actually going to launch them out into space off of the rocket.
November 2018. With the Electron rocket ready for final integration and launch, the CubeSats are shipped from California all the way to Auckland, New Zealand. But the Electron rocket elements and all the ELaNa 19 CubeSats still have to make one more journey on Earth. It takes a caravan of trucks about 8 hours to make the 575-kilometer journey from Auckland to Rocket Lab's Launch Complex 1 at Mahia Peninsula on the island's east coast. But this remote launch site is worth the drive.
So from one single launch site, we can launch all the way to 39 degrees inclination, that's due east, all the way up to sun synchronous, which is about 98 degrees depending on the altitude. So that's the widest range of inclinations available from any launch site in the world.
On the ground at the Mahia Launch Complex, the rocket's stages are carefully brought together and inspected to ensure everything is perfect. The CubeSats are installed on the Electron payload plate, the interface between the rocket and the satellites. Then ELaNa 19 is encapsulated inside the Electron rocket's payload fairing, where the CubeSats will stay until they're in space. The entire rocket is manually rolled out to the launch pad for a rehearsal of the launch day that's quickly approaching. Liftoff is planned for December 12, 2018, and the vehicle is ready. But dangerously strong winds keep the Electron on the ground for 4 more days. Their fortunes change on December 16th when the winds aloft finally go green.
5, 4, 3,
Mission.
2.
The Electron rocket's 9 Rutherford engines ignite, and history is made. Less than an hour into the flight, the ELaNa 19 CubeSats are released. Instead of hitching a ride, these small spacecraft have a dedicated ride that can deploy each one to just the right orbit for maximum science. ELaNa gives students and teachers a low-cost pathway to space to test new technologies, make new discoveries, and create new connections to each other and the future. Small satellites, big dreams, and even bigger potential for future CubeSats needing a venture-class ride into space. To launch with ELaNa, visit nasa.gov/ELaNa.